Hello my dear students, I welcome you to NEET World. So in this session, we will be studying about oxidation and reduction reactions, okay? So this is one of the most useful video for your preparation, okay? So in the last class, we have discussed about types of chemical reactions. What are the types of chemical reactions? Here we have one is combination, next decomposition, next displacement, double displacement and redox reactions. The first four we already covered. Now let us discuss about redox reactions, okay? So before going to start the session, please click on the like button because I know you are definitely going to like the session. After completing this session, you will definitely feel like you have learned something and you can easily solve the questions based on this particular topic. So just click on the like button and let us start our topic here, okay? So what exactly oxidation and reduction process here? Look here, see, there are different ways to express what exactly the oxidation and reduction, okay? So now the basic one here is oxidation means addition of oxygen can be considered to be oxidation process, or removal of hydrogen is also considered to be oxidation process. For example, here I have an element A I have, okay? To this, if I add oxygen atom, okay, if I add oxygen to this particular molecule, so addition of oxygen to this species is considered to be what? See, here it is forming oxide. So this process is what? Oxidation process. I hope it is clear. Now, for example, I have one more thing here, one more way of expressing the same definition. Removal of hydrogen is considered to be also as oxidation. So it means, for example, I have AH2. So from these two hydrogens I am removing, at least one hydrogen I am removing. So what happens? It is becoming AH. So now here removal of hydrogen, in this, during this process also one hydrogen atom is removed. So this process is also considered to be oxidation process only. So these are the just simple examples I have mentioned, okay? We will discuss the clear cut examples, just hold on for some time, okay? So now next we have here, here we have reduction. What exactly reduction here? See, addition of hydrogen. For example, A is a element. To this I am adding hydrogen atoms, therefore it is becoming AH2, okay? So what is this process? Addition of hydrogen is considered to be reduction. Addition of hydrogen is considered to be reduction. And one more way we can express is removal of oxygen. For example, here I have AO2 and from here I am removing this oxygen, it is becoming A. So now oxygen atom is oxygens are removed, so this process is also what? Reduction. I hope these are clear. Now oxidation, reduction will be having like opposite definitions, right? So here addition of oxygen is called oxidation, removal of oxygen is called reduction. Again, addition of hydrogen is called reduction and removal of hydrogen is called oxidation. I hope there is no confusion, it is clear, right? Now let us see few more examples to get more clarity on this particular topic, okay? Now look here, I have zinc oxide, ZnO. When we treat with carbon, it is forming zinc plus carbon monoxide. So in this process, see, zinc oxide is becoming zinc. It means what is this process? See, it is loses its oxygen atom now. So it means removal of oxygen is what? Removal of oxygen is what? Removal of oxygen. Here you can say removal of oxygen is what? Reduction. So you can write reduction, okay? Now see, this carbon is converting into carbon monoxide. So addition of oxygen is taking place. So that process is what? Oxidation. So oxidation. So this is what? Reduction. So I hope it is clear how we can identify oxidation and reduction in a particular reaction, okay? So here I have mentioned the points also. So zinc, see, zinc oxide is loses oxygen and so this process is what? Reduction. And carbon is gaining oxygen, becoming carbon monoxide, so gain of oxygen is oxidation. So like this you should get some clarity on a particular topic whenever you are preparing for any exam, okay? I hope it is helpful for you, right? Now see, in a particular reaction, if both oxidation and reduction are taking place simultaneously, then we can say that process as redox reaction. See, here reduction is taking place, so I can write okay, and here oxidation is, see here reduction is taking place, so I am writing red, and oxidation is also taking place, ox. So redox reaction. So in a given chemical reaction, both oxidation and reductions are taking place, then those kind of reactions are considered to be redox reactions. I hope it is clear, right? Let's move on. Now here we have second example. See, iron oxide Fe2O3 becoming iron. So what is the process here we are seeing? It is losing 3 oxygen atoms from here. So I can say the loss of oxygen. What is the loss of oxygen? Reduction, right? Okay. Now aluminum is gaining oxygen and becoming its oxide, aluminum oxide. So gain of oxygen, oxidation. I hope it is clear. So you can write in the short format. So just for clarity purpose, I hope it is clear, right? So oxidation, reduction I have mentioned. So that is the first definition I explained. What is the second definition I explained with respect to hydrogen? First definition is with respect to oxygen, second definition with respect to hydrogen. So what I told you, like removal of hydrogen is oxidation, addition of hydrogen is reduction. See here we have sulfur having 2 hydrogens, H2S, hydrogen sulfide we can say. So now this H2S, when it is reacting with oxygen, forming 2 sulfur atoms and becoming water molecule here. We are getting a water molecule here. So here from this H2S, it is losing 2 hydrogen atoms and becoming sulfur. So in this process, what we have seen? Loss of hydrogen, loss of hydrogen. So loss of hydrogen is what? Oxidation. So what is that? Oxidation. Now this oxygen is gaining that hydrogen and becoming H2O. So for this process I can say addition of hydrogen or gain of hydrogen is what? Reduction. So reduction. So this is how you need to identify. Therefore all these three reactions are examples for redox reactions, right? Okay, let's move further here. So now we have seen how oxidation reduction reactions are there and how can we identify them, right? Now how can we calculate the oxidation number in a particular compound? Let us discuss about that. Okay, now what exactly oxidation number or oxidation state? Let us discuss here. Oxidation number or the state of an atom is a charge present on the atom in a molecule or ion, which is calculated on the basis of the rule, that is electron pair in the bond is entirely transferred to more electronegative atom. Okay, just wait, I will explain, no worries. Okay, for example, here I have water molecule H2O I am writing. Okay, now in this water molecule we have hydrogen atoms 2 and 1 oxygen atom, right? So but which is more electronegative? This is a covalent molecule, right? So let us write its structure properly like this. Okay, it will be having bent structure, we will discuss about structures later, but the structure will look like this, you can remember. Okay, now out of these 2 atoms, which is more electronegative? We know oxygen is the one of the most electronegative element in the periodic table, right? What is the first most electronegative element? Fluorine. After that oxygen. So fluorine is the first most electronegative element in the periodic table. Okay, oxygen is the second most electronegative in the periodic table. So these 2 statements you have to remember. Okay, now so if it is more electronegative, it means the bonded electrons are there now in this bond, that will be taken towards oxygen side only. Therefore if these electrons are taken towards oxygen side, so what is the charge remaining on this hydrogen? If these 2 electrons are taking place, it will becomes H plus. Because why it is happening like this? Because oxygen is more electronegative element. Okay, similarly this side also, this hydrogen is less electronegative than this oxygen, so this bond also considered to be taken by oxygen atom. Therefore this is also becoming H plus. Now oxygen is taking electrons from both sides now. This side 1 electron from this hydrogen, and here also hydrogen electron is taken by the oxygen only. Therefore oxygen is taking 2 electrons from this side and this side, therefore it becomes O minus 2. So now what is the oxidation state of hydrogen in water molecule? It is +1. So this is the charge present on the hydrogen, that is what? +1. Similarly for this hydrogen also +1. Now what is the charge present on this oxygen after removing these bonds in such a way by considering their electronegativities? It is -2. Therefore oxygen in this molecule will be -2. Oxidation state is -2. I hope this is clear, right? Okay. Now I will be asking you one question. So just try to identify the answer for this. So I am writing CO2 molecule. Now what is the oxidation state of carbon in this molecule? Okay. So tell me in the comment box. Okay. So this is considered to be homework question. Okay. I hope this is clear. Up to here it is clear. If you are still having any confusion, just go back and watch it. Just go back, little more seconds, go back and watch it. Okay. Now let's have clear discussion on how can we assign oxidation states, okay, for different compounds or different elements, let us say. Okay. Here the first rule, we have some rules to be followed here. Very important, very basic and very important. You can see many questions in NEET, JEE, EAP set, whatever the competitive exam you are going to write. Okay. So because it is very fundamental and very important topic. Okay. Look here, rules for assigning oxidation number. Okay. The oxidation number of atoms in their elementary state is always 0. So what exactly it is? The oxidation number of atoms in their elementary state. For example, some elements will exist in diatomic form like hydrogen, oxygen, nitrogen. How they will exist in the nature? They will be in the diatomic form like H2, O2, N2, like that. And some elements are existing in their polyatomic form. For example, phosphorus exists in P4 form, okay, and sulfur exists in S8 form. So whenever an element is combined with itself, the oxidation state for those elements will be considered to be 0. For example, here I am writing O2. Okay. Now oxygen is combined with itself, right? So this is the standard elementary state of this particular oxygen. So the elementary state, whenever you are taking any element, in its elementary state, oxygen state will be considered to be 0. For example, here I am writing sodium. Okay. Is there any charge on this element? So this is how the element, this sodium will exist, right? So the elementary state on this species is 0. Okay. There is no charge, so it is considered to be 0. Okay. I hope it is clear. For example, iron I am writing. Okay. So is there any charge on this element? No. Therefore the oxidation state for this element is 0. I hope it is clear, no confusions, right? So I am writing S8. So what is the oxidation state of sulfur here? So it is combined with itself, therefore there is no electronegativity difference. So the charge will be, oxidation state will be 0. I hope it is clear, no confusions, right? Okay. Let's discuss little more about these things. Here the second statement, oxidation state of monoatomic ions is same as their charge. For example, here I am writing iron, okay, here I am writing iron +2 and here I am writing Fe +3. So what are the charges here? See, this is the elementary state of iron. So there is no charge, therefore its oxidation state is 0. Now here iron with +2 charge. So whenever an element is written with some charge, then that charge is its oxidation state. So for this +2 is the oxidation state. For this +3 is the oxidation state. I hope it is clear. Now tell me for Cu +1. So +1 will be the oxidation state. I hope it is clear, no confusion, right? And now tell me for Cl-. Yes, -1 charge. So therefore that will be the oxidation state of chlorine here, right? Okay. I hope it is very clear, right? So if it is really clear, just write in the comment box. If you have any difficulties, if you are really liking, just click on the like button once again. Okay. Now the sum of oxidation states in a neutral compound is 0. So what exactly it is? So let us take one neutral compound here. So I am taking H2SO4. Okay. So let us take this. Okay. So this is one example. Okay. Now before going to this, let us say this is second example. Let us take one smaller example here. Okay. I am taking here HCl. This is a simple molecule, right? So overall molecule is looking what? It is looking neutral, right? There is no charge on this. Therefore the total charge, the sum of oxidation number in the neutral compound should be equals to 0. Yes, it should be equals to 0. So now out of these two, which is more electronegative element, hydrogen or chlorine? We know chlorine is more electronegative element. Therefore here the bonded electrons are taken towards the chlorine. So I can say how many chlorine atoms are there? One chlorine atom is there. So let us say its oxidation state we need to find. Consider it as X. Now hydrogen is less electronegative. How many atoms are there? One atom is there. So for each hydrogen atom, see, only one bond connection is there. So if this bond, sigma bond, is taken towards chlorine, so what is the charge remaining on this hydrogen? It will be +1, right? So now what is X here? So X can be equals to here +1. If I send that side, it will become -1. So this is a very basic example. Just to avoid confusion, I have explained this. Now let us discuss about this. Okay. Now I want to find the oxidation state of this sulfur. Let us say this is X. Okay. We need to find the value of X here. Now overall molecule is looking like there is no charge. It's a neutral, right? So overall should be equals to 0 we should take. Okay. Now here hydrogen atoms are there. How many are there? 2 are there. Now which is more electronegative, hydrogen or sulfur? We know sulfur is more electronegative than hydrogen. Therefore 2 hydrogens, so therefore the 2 hydrogens will lose one electron towards the sulfur, therefore it will be having +1. So always a mono, if there is only one bond with one particular atom, then after removing that bond, the species will get how many bonds we remove? One bond, no? So it will get one positive charge. If it is having two bonds with any other element, between two elements, if the bonds are removed, then the +2 charge will be coming on that the removed atom. Okay. So now here just look here. So now how many sulfur atoms are there? 4. Now tell me, out of this sulfur and oxygen, which is more electronegative? We know oxygen is more electronegative. We have 4 oxygen atoms. So 4 into what is the charge on each oxygen atom? So always remember, so these are the standard rules to be followed. Okay, always remember, whenever oxygen is attached to other less electronegative atom, out of sulfur and oxygen, we know oxygen is more electronegative element, right? So whenever it is attached to other element, see, we know oxygen is having 2s2 2p4 electronic configuration, 6 electrons are there. If we give 2 more electrons, its octet will be fulfilled, right? It will become 8 electrons in its octet. Therefore it required 2 more electrons. So whenever oxygen is attached to any other less electronegative atom, it will be taking 2 electrons, therefore oxygen becomes -2. Therefore each oxygen will be having how much charge? -2 charge. So I am writing 4 into -2 equals to 0. I hope it is clear why I have taken in this manner. Overall molecule is neutral, therefore it is equals to 0. Okay, 2 plus x minus 8 equals to 0. X will be, see, plus 2 minus 8 minus 6. If we send that side, it will become plus 6. So plus 6 is the oxidation state of this sulfur. I hope this is very clear without any confusions, right? Okay. So now I will be giving you one question for your practice purpose. Okay. Now give me the oxidation state of phosphorus in this H3PO3. So for phosphorus, consider X. What is the value of X? This is the question number 2. You should say me the answer in the comment box for this particular question. Okay. Let's move further. Next, for polyatomic ions. So let us say one polyatomic ion, here I have sulfate ion I am taking, SO4 2 minus. See, polyatoms, more than one atom, right? So we have polyatoms, polyatomic ions. The sum of oxidation number is equal to the charge on the ion. So what is the charge here? We have -2. It means, for example, we need to find for sulfur, let us say X plus how many sulfur atoms? 1. So 1 into X plus 4 oxygen atoms, 4 into each oxygen I told you -2 because it is divalent atom. Okay. Next, what is that overall charge? -2. That's it. So we got, what is the oxidation state of sulfur here? X will be -8. If we send this side +8, -2. Therefore it is +6. This is how we need to do the oxidation state calculation. Next, so I told you already, generally oxygen having -2 oxidation state except in peroxides. So except in peroxide, it will be having -2 charge. Example is H2O2, hydrogen peroxide we are saying now. So in this oxidation state of oxygen will be -2. Okay. So whenever oxygen is having -2 charge, so we will be saying this as oxide. Okay. So whenever oxygen is having, see, 2 atoms with -2, for one atom it will be -1, right? Okay, so whenever oxygen is in -1 oxidation state, we should say peroxide, peroxide. Okay, best example is hydrogen peroxide. Okay, now sometimes oxygen will be having -1/2 charge. For example, all the alkali metals, remember all the alkali metals like sodium, potassium, lithium will exist with +1 charge. If it is +1 charge, so let us say here I have KO2. So in this case, what I told you, oxidation state of potassium is always +1. Okay, now if it is always +1, the negative charge on this should be always, here it should be -1. Okay, for O2 molecule it is -1. For O2 oxygen, here 2 oxygen atoms are there now, so 2 oxygen atoms. So divide this -1 by into 2 parts, so it will becomes -1/2, -1/2. So whenever we have oxygen with alkali metals like KO2 form in this manner, so we can say this oxygen as superoxide. What is that? Superoxide. What is the oxidation state of oxygen in superoxides? It is -1/2. I hope it is clear without any confusion, right? Next, hydrogen is +1, but in metal hydride it is -1. So always remember, alkali metals are highly electropositive, they always contain +1 oxidation state. Now if hydrogen is attached with the sodium, so it should be +1 and hydrogen will be having -1. So this is finding the oxidation state is purely based on the electronegativity difference here. Okay, now whichever the electronegative atom is there, give the negative charge for that, and for electropositive atom or less electronegative atom, give positive charge. That's it, that's it, very simple. Okay, now see here they are saying oxygen is attached to fluorine. So I told you which is more electronegative out of these two. So I told you here oxygen is less electronegative than the fluorine, because fluorine is highest electronegative element in the periodic table. Therefore here it will be having like this. So these bonds are taken towards fluorine, so F minus here, here also F minus, therefore oxygen will be having O+2. So whenever we have oxygen bonded with fluorine, so it will be having positive oxidation state. So +2 in this case and -1 for fluorine and this fluorine also. I hope it is very clear, right? Now tell me for this, so my question to you is homework question again this is. Okay, now here O2 F2 I am giving. So what is the oxidation state of oxygen here? What is the oxidation state of oxygen in this case? So write in the comment box. Okay, oxidation state of oxygen atom in O2 F2. So this is question number 3. You should answer. These are the 3 homework questions I give it. Okay, now identifying the oxidation reduction using oxidation number. Okay, in any process, for example, look here, zinc. Is there any charge on zinc metal here? No. So oxidation state is 0. It is converting into Zn+2. Here I am rewriting the same thing, copper +2 giving rise to Zn+2 and copper. Okay, so if there is no charge on any in a particular element, so consider the charge is 0. So 0 is converting into +2 form here. So it means the number is increased. Increase in oxidation number is what? Oxidation. So if the number is increased, that process is called oxidation. Okay, here -2 is becoming 0. So this decrease in number, decrease in oxidation number is what? Reduction. I hope these 2 definitions are clear, identifying oxidation and reduction, right? Next, oxidation. Next, so what are the definitions we discussed? Addition of oxygen, removal of hydrogen is called oxidation, or removal of oxygen and addition of hydrogen is called reduction, right? Now we have one more kind of definition. Let us look here. Reduction reactions and electron transfer between the atoms. So sometimes here the oxidation, this is a modern definition here. Oxidation is a process in which atom or ion loses 1 or more electrons. Okay, so it will be, see, oxidation is a process in which an atom or ion loses 1 or more electrons. So this process is what? Oxidation. So I can say loss of electrons is called oxidation and gain of electrons is called reduction. So I hope these are clear, right? Now let us look here. I have sodium, okay, and I have chlorine, okay. So both are in the in their elementary states. Okay, so the 0 oxidation number. So now here I have 2 sodium atoms becoming Na plus. So in this process what happens here? Gain in the charge, right? So gain in number. So this process is what? Oxidation. Okay, now chlorine here, it is in 0 oxidation state becoming Cl minus, 2Cl minus. So the number is reduced from 0 to -1. So this process is what? Reduction. Okay, so this is how you need to understand the concept and identify the reactions. Okay, so we discussed about this thing. So look here, I have given one more thing. Say loss of electron is oxidation. Sodium losing electron and becoming plus. So this is what? Oxidation. Chlorine gaining that electron becoming minus, number is reduced. So gain of electron, reduction. Okay, so zinc is losing electron and becoming Zn plus 2. So I can say that process is loss of electron is oxidation. Here copper is gaining plus 2 to 0, gaining the electrons and becoming neutral atom. So this is number is reduced, charge is reduced, so reduction. I hope this is clear, right? Okay, so now in a reaction, if both oxidation, reduction are taking place, so we can say redox reaction, right? I hope this is also clear. Now what are the real life examples? Rusting of iron is what? See, iron is converting into iron oxide. So this is what? Oxidation process. Combustion, carbon here gaining, see it is losing hydrogen atoms and gaining oxygen. So gain of oxygen, what? Oxidation. I hope these are clear. Now see carbon dioxide, here already carbon is in maximum oxidation state plus 4. It is converting into like see in this process it is gaining hydrogen, it is converted into carbohydrate form, right? So it is gaining hydrogen. So what is that? Gain of hydrogen is what? Reduction. So photosynthesis process, carbon is undergoing reduction process. In respiration it is opposite to above process. See here carbon is gaining oxygen and becoming carbon dioxide. So this process is what? Oxidation. I hope it is clear, right? So this is reduction, this is oxidation, oxidation and oxidation. Okay, I hope these are clear, which we are seeing in our daily life. Okay, let's move here. And oxidizing and reducing agents, this is also important thing. So gain, see oxidizing agent means that gains electrons and gets reduced. So oxidizing agent means, see it will oxidizes others and reduces itself. See it is gains electron and getting reduced. So for example here you can see one more thing, reducing agent also will see loss of electrons and gets oxidized. Reducing agent means what? Reduces others, oxidizes itself. What is reducing agent? Reduces others, other species and oxidizes itself. That is what the reducing agent. Okay. Now here zinc is in 0 oxidation state converting into plus 2 because sulfate ion I told you -2 charge. Okay. Now see during this process what we are observing, so it is undergoing oxidation and reducing this species. So what I can say, if an element is undergoing oxidation and reduces others, see it is reducing, zinc is reducing this copper, right? So copper, right? So copper plus 2 is converting to copper. So if an element is undergoing oxidation and reduces others, see reduces others, so it means it is a reducing agent. So I can say zinc is reducing agent. Okay. Now copper plus 2 is converting into copper 0, it means its oxidation number is reduced. Okay, it means it is undergoing reduction and oxidizing this species. So I can say copper plus 2 is oxidizing agent. I hope these are clear, right? Next, what are the summary here? We have these things to be summarized here: oxidation, loss of electron, gain of oxygen, okay, and loss of hydrogen. These are the oxidation processes. Reduction, gain of electron, loss of oxygen or gain of hydrogen. This is what the things happens in the reduction process. Okay, redox reactions means combination of both. Okay, so these reactions are vital in chemical and biological systems, right? We already seen our daily life applications also. Okay, now this is about the session. So in the next session I will be bringing few questions which are asked in NEET, JEE and EAP set and other entrance exams, which are very useful. It is completely based on this topic only. Okay, so stay tuned with us. So happy learning. Okay, thank you.